Hello students, I hope you all are fine out there. So we are doing exercise 21A, isn't it? So in our previous videos we have already completed till question number 35, and today we'll start from question number 36 onward. Okay, so let's begin. So this is question number 36 from exercise 21A. Okay, prove trigonometric identities. So we have cos A upon 1 minus sin A in the left hand side, and we are asked to prove this equals to sec A plus tan A. Okay, so these sums are very simple. All you need is practice. When you practice, you will get the idea how to solve this type of problem. Okay, let's begin. So left hand side equals to, we have cos A upon 1 minus sin A, isn't it? Cos A upon 1 minus sin A. Now let's multiply this by 1 plus sin A in the numerator and in the denominator as well. 1 plus sin A. Okay, we can do this. Suppose we have 5 here, we can multiply by 2 and divide by 2. So this 2 and 2 gets cancelled, and 5 into 1. So 5 into 1, this 2 and 2 get cancelled, and 5 into 1 means 5, isn't it? So this can be done like this: 1 plus sin A by 1 plus sin A. This 2 can be cancelled. Okay, now in the numerator we have cos A into 1 plus sin A, isn't it? So let's write that: cos A into 1 plus sin A. This is in the numerator, and in the denominator we have A minus B into A plus B. Okay, let's assume this one as A and sin A as B. So A minus B into A plus B gives us A square minus B square, isn't it? So A square is 1 square, 1 square means 1, and B square is sin square A, isn't it? So this is 1 minus sin square A. So in the numerator we have cos A into 1 plus sin A, and in the denominator we have 1 minus sin square A. This gives us cos square A, isn't it? We know that sin square A plus cos square A equals to 1. So cos square A equals to 1 minus sin square A, isn't it? This is the formula. From here we get cos square A equals to, this plus sin square A goes to the right hand side and becomes minus sin square A. So in the numerator we have cos A, and in the denominator we have cos square A. So cos A and this cos A gets cancelled. So still we have 1 cos A in the denominator. Okay, 1 plus sin A upon cos A, isn't it? This can be written as 1 upon cos A plus this sin A upon cos A, isn't it? This cos A, suppose we have 5 upon 2 plus 3 upon 2. We can take the LCM of this 2 and write like this: 5 plus 3. So 5 plus 3 upon 2 can be written as 5 upon 2 plus 3 upon 2. Same thing, 1 plus sin A upon cos A can be written as 1 upon cos A plus sin A upon cos A. So 1 upon cos A is sec A, isn't it? 1 upon cos A means sec A. Cos A when goes to the numerator becomes sec A, plus sin A upon cos A means tan A. We know the formula, isn't it? So this is what we have in the right hand side: sec A plus tan A equals to prove RHS. Hence proved. Okay, I hope you are getting me. Now let's go to the next question. Question number 37. Okay, in the left hand side we have sin A into tan A whole upon 1 minus cos A, and we are asked to prove this equals to 1 plus sec A, isn't it? So this sin A, this tan A can be written as sin A upon cos A, isn't it? Sin A upon cos A. Okay, tan A means sin A upon cos A, whole upon we have 1 minus cos A, isn't it? 1 minus cos A. So let's multiply by 1 plus cos A in the numerator and in the denominator. Okay, 1 plus cos A. I am multiplying by 1 plus cos A in the numerator and 1 plus cos A in the denominator. The value of the expression does not change because this and this can be cancelled. Okay, so Sin A into sin A is sin square A, isn't it? In the numerator we have sin square A upon cos A. Cos A into 1 plus cos A, isn't it? Cos A into this 1 plus cos A is here, actually 1 plus cos A is in the numerator, 1 plus cos A. Okay, so 1 minus cos A into 1 plus cos A minus B into A plus B gives us A square minus B square, 1 minus cos square A, isn't it? A minus B into A plus B means A square means 1 square is 1 minus B square is cos square A. Okay, so sin square A into 1 plus cos A, this number is in the numerator. Okay, sin square A into 1 plus cos A whole upon, we have cos A here, into 1 minus cos square A means sin square A, isn't it? Sin square A. 1 minus cos square A means sin square A. Actually below this number there is 1, so when we multiply this like this, this 1 goes up and this 1 minus cos square A comes in the denominator, isn't it? So this gives us sin square A in the denominator. So this sin square A and sin square A can be cancelled. So we have 1 plus cos A upon cos A. So let me continue this here. 1 plus cos A upon cos A can be written as 1 upon cos A, isn't it? 1 upon cos A plus cos A upon cos A plus cos A upon this cos A. Okay, so 1 upon cos A is actually sec A plus cos A and cos A cancels out, so here we have 1, sec A plus 1. So this is 1 plus sec A, isn't it? So sec A plus 1 and 1 plus sec A is same thing, 1 plus sec A. Okay, equals to RHS, hence proved. I hope you are getting me. Okay, now let's do another question, 38. Number 38. Okay, in the left hand side we have 1 plus cot A minus cosec A into 1 plus tan A plus sec A, and in the right hand side we have 2, isn't it? So let's prove this. LHS equals to 1 plus cot A minus cosec A whole 1 plus tan A, 1 plus tan A plus sec A, isn't it? Plus sec A. So 1 plus this cot A means cos A upon sin A, isn't it? Cos A upon sin A. Cot A can be written as cos A upon sin A. This minus cosec A minus cosec A means 1 upon sin A. So let's write this also. 1 plus tan A means sin A by cos A, isn't it? Tan A means sin A by cos A plus sec A means 1 upon cos A. Are you getting me? This sec A means 1 upon cos A. Okay, so let's take the LCM. Sin A, here we have 1 sin A and sin A, LCM will be sin A. Sin A will be the LCM. So here we have 1 into sin A gives this sin A, so that sin A into 1 is sin A plus this plus comes here. Sin A into 1 is this sin A, so 1 into cos A is cos A, isn't it? So minus this sin A into 1 is sin A, so 1 into 1 is 1, bracket close, and here we have 1 in the denominator of this one, so the LCM of 1 cos A and cos A will be cos A, isn't it? So 1 into cos A is this cos A, so that cos A into 1 is cos A. Are you getting me? So this cos A into 1 is this, so that 1 into sin A is sin A plus cos A into 1 is this, so 1 into 1 is 1. So now let's assume this sin A plus cos A as A and 1 as B. Okay, sin A plus cos A and this one as B. So A minus B, see here, A minus B, A plus B. This cos A plus sin A and sin A plus cos A, same thing. Okay, 2 plus 3 and 3 plus 2 is same thing. Both of them gives 5, isn't it? So sin A plus cos A is A, cos A plus sin A is also A, okay, because sin A plus cos A and cos A plus sin A is same thing. So A minus B into A plus B, isn't it? A minus B into A plus B gives us A square minus B square. So A is sin A plus cos A, A square minus B square. B square is 1 square, isn't it? B is 1, so 1 square is 1. So we need not write a square here. In the denominator we have sin A into cos A. So sin A into cos A. Now sin A plus cos A whole square. A plus B whole square means A square plus B square plus 2AB, isn't it? We know the formula. A plus B whole square means A square plus B square plus 2AB, and this minus 1 comes here, minus 1. In the denominator we have sin A into cos A, sin A into cos A, okay. So this sin square A plus cos square A means 1. So let me continue here. Sin square A plus cos square A means 1, isn't it? Sin square A plus cos square A is 1 plus 2 sin A cos A plus 2 sin A cos A minus 1, this minus 1 whole upon, in the denominator we have sin A cos A, isn't it? Sin A dot cos A. So this plus 1 and minus 1 can be cancelled, isn't it? So now remains 2 sin A cos A upon sin A cos A, 2 sin A cos A upon sin A cos A. So this sin A cos A and sin A cos A can be cancelled. So now remains 2. This is what we have in the right hand side, hence equals to RHS, hence proved. I hope you got this. Now let's move on to the next question, that is question number 39. Now let's do question number 39. We have root under 1 plus sin A upon 1 minus sin A in the left hand side, and we are asked to prove this equals to sec A plus tan A, okay. So let's copy this left hand side. LHS equals to root under 1 plus sin A into 1 minus sin A upon 1 minus sin A, isn't it? So let's multiply this number by 1 plus sin A in the numerator and in the denominator as well, okay. 1 plus sin A. We can do this because the value of the expression does not change. This and this can be cancelled, isn't it? So I am multiplying both the numerator and denominator by 1 plus sin A, okay. So this gives us 1 plus sin A into 1 plus sin A. 1 plus sin A into 1 plus sin A means 1 plus sin A whole square, and in the denominator we have A minus B into A plus B, isn't it? 1 is A and sin A is B, okay. A minus B into A plus B means A square minus B square. A square is 1 square, 1 square means 1. So B square is sin square A, isn't it? Now this square and this root can be freed, isn't it? So 1 plus sin A remains in the numerator. This square and this root can be cancelled, but in the denominator we have root, okay. This root was for both the numerator and denominator. Here we have square, so this root is freed from the numerator, and in the denominator 1 minus sin square A means cos square A, isn't it? 1 minus sin square A means cos square A. So 1 plus sin A is in the numerator, and in the denominator we have cos square A. Now we have square and this root, isn't it? So this cos square A can be freed, so cos A remains without root, okay. This square and this root gets cancelled. So we need to prove this, isn't it? This means, let me continue here, okay. 1 upon cos A plus sin A upon cos A, isn't it? 1 upon cos A plus sin A by cos A, okay. So 1 upon cos A means sec A, isn't it? Plus sin A by cos A means tan A. So this is what we have in the right hand side, sec A plus tan A equals to RHS, hence proved. Question number 40. this question is similar to question number 39. Okay, so in the left hand side we have root under 1 minus cos a, isn't it, whole upon 1 plus cos a. So let's multiply the numerator and denominator by 1 minus cos a. Okay, 1 minus cos a upon 1 minus cos a. Now this 1 minus cos a and 1 minus cos a can be cancelled, and the value of this expression, or the, you can say, fraction, does not change. Okay, so in the numerator we have 1 minus cos a into 1 minus cos a, that means 1 minus cos a whole square, and in the denominator we have a plus b into a minus b, isn't it? 1 is a and cos a is b. Okay, so a plus b into a minus b means a square minus b square. A square means 1 square, so 1 square is 1, isn't it? So here we have a square and this root can be cancelled, so in the numerator we have 1 minus cos a. Okay, now this 1 minus cos a is free from root, and this square and root is cancelled. Okay, now in the denominator we have root because there is no square, isn't it? So let's change this into sin square a form. 1 minus cos square a means sin square a, sin square a, isn't it? So in the numerator we have 1 minus cos a, and in the denominator we have sin square a. Now we can cancel this square and this root, so sin a remains now. Okay, actually let me tell you this, sin square a means root under sin a into sin a, isn't it? So this 2 sin a can be taken out of the root, making a pair, and simply write sin a. Okay, now this sin a is free from root. Got my point? Okay, now if there was cube root, that means pair of 2 cannot be taken out, pair of 3 is needed. Okay, if this is like this, sin a into sin a into sin a. Okay, suppose we have like this. This is just an example. We have cube root of sin a into sin a into sin a into sin a. 1 2 3 4, sin to the power 4a, isn't it? This is a. Okay, sin to the power 4a, but we have cube root. Now 1 2 and this 3, we make 3 pair and take this out, so sin a comes out, isn't it? And cube root of this sin a remains within, because this sin a does not have 3 other pairs, isn't it? So we do like this. I hope you got this. Now let's come back to the point. Here we have sin square a under root, so this square and root can be cancelled and sin a remains. So 1 minus cos a upon sin a is actually, let me continue here, 1 upon sin a minus cos a upon sin a, isn't it? 1 upon sin a minus, this minus comes here, cos a upon sin a, cos a upon sin a. So 1 upon sin a is actually, when you take sin a to the numerator, it becomes cosec a. So cos a upon sin a is cot a. So this is what we have in the RHS, isn't it? So this is RHS. I hope you got this. Now let's do question number 41. Okay, so question number 41, this is very important question because this question has been asked in the icse examination in the year 2000 and in the year 2003. Okay, so this is one of the important question. Let's do this. In the left hand side we have LHS equals to root under 1 minus cos a upon 1 plus cos a, isn't it? This is what we have in the left hand side. So now we need 1 plus cos a in the denominator, so we should not multiply like the previous sum. What we do is we multiply with 1 plus cos a upon 1 plus cos a. The signs remain same. In the previous sum we just changed the sign, isn't it? Because we did not need this 1 plus term in the denominator. Now here we need 1 plus cos in the denominator, so 1 plus cos a into 1 plus cos a. Okay, so we multiplied this fraction by 1 plus cos a upon 1 plus cos a. Okay, this and this can be cancelled. So now let's do this. A minus b into a plus b is actually a square minus b square, isn't it? a minus b into a plus b is a square minus b square. So 1 plus cos a into 1 plus cos a is 1 plus cos a, 1 plus cos a whole square. Now root under 1 minus cos square a is actually sin square a, isn't it? So 1 plus cos a whole square, 1 plus cos a whole square. Now let's remove the root. Here we have sin square a, this square and this root can be cancelled, so sin a. Okay, and in the denominator we have 1 plus cos a whole square, and this square and root can be cancelled, so 1 plus cos a. Okay, so this is what we have in the right hand side, equals to RHS. Hence proved. This question is similar to question number 41. So let's do this. In the left hand side we have LHS equals to root under 1 minus sin a into 1 upon 1 plus sin a, isn't it? 1 plus sin a. So let's multiply with 1 plus sin a in the numerator and in the denominator. Okay, 1 plus sin a, 1 plus sin a, because we need 1 plus sin a in the denominator, isn't it? So this gives us a minus b into a plus b, isn't it? So a square minus b square. In the denominator we have 1 plus sin a into 1 plus sin a means 1 plus sin a whole square. So 1 minus sin square a means cos square a, and 1 plus sin a whole square, 1 plus sin a whole square, isn't it? Now this square and root can be cancelled in the numerator, square and root, so cos a remains. Okay, and in the denominator 1 plus sin a whole square, isn't it? So square and root should be cancelled, 1 plus sin a. Okay, so this is what we have in the right hand side, equals to RHS. Hence proved. I hope you got this. Thank you so much for watching this video. I hope you understood the concept. Keep practicing, because unless you practice yourself you are not going to learn. Okay, keep practicing, and if you find difficulties in any sum, then you check out the video again, rewatch the video, try to understand the concept and try to solve the questions by yourself. Okay.